Okay, now we're getting ready to look at this problem. Before we look at Desmos, I thought I'd show you how to use Wolf. I'm not sure you can get into the online room as a student, but in case you can, if you click this button right here, Wolfram Alpha, and you type in the limit as n approaches infinity of what have we got? We've got, I think if I remember it correctly, it's negative 4n factorial divided by 2 hat n. And I got to end the parentheses. Let's see if Wolfram Alpha returns something for that. There it is. Okay, and I can add the content to the board if I want to. Okay, so Wolfram Alpha is telling us that the limit of this sequence is negative infinity. And let's see if Desmos confirms that. I'll go to problem number 15. And I'll bring it, I don't want to highlight that. I want to bring the table into focus. Ooh. Oh, there we go. There we go. Okay, so it looks like as n gets bigger and bigger, this table confirms it. When n is 10, we're already down at negative 14,175. And if I go to 20, look how big that number is. So it looks like Desmos confirms that the limit of this sequence is negative infinity. How could we show that? Well, this takes a little bit of trial and error. Okay, let's see if we can rewrite this part in a way that kind of confirms what's happening. So I can write this as negative 4. Well, you know what? Sometimes it's a good idea to start listing some elements of the sequence to get an idea of what's happening. So when n is 1, I get negative 4 times 1 factorial, which is just 1. I'm going to use a dot, over 2. 2 to the 1 is 2. So this is negative 2. A sub 2 is equal to negative 4 times 2 factorial, which is 2 times 1 divided by 2 to the nth. 2 to the second is 2 times 2. And I get negative 2 again. And what's a sub 3? Well, it's negative 4 times 3 factorial, 3 times 2 times 1, over 2 to the third, 2 times 2 times 2. And by doing this, I'm starting to see what I might be able to do for a sub n. A sub 4 is negative 4 times 4 factorial, 4 times 3 times 2 times 1, all over 2 to the 4th. And I'm writing it this way so that you can see that the number of factors of 2 in the denominator matches the number of factors of n factorial. So in fact, a sub n is equal to negative 4 times n factorial. N times n minus 1. Let me move this out of the way. Times n minus 2 dot 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 until I get to 1. And in the denominator, I'm going to have n factors of 2. till I get to here. Okay, so when I write a sub n this way, what is the limit of this expression as n approaches infinity? Well, I've really got this -4 sitting out front. Then I've got, I could picture this as n over 2. I could picture this as n minus 1 over 2, n minus 2 over 2, dot, 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 until I get to 1/2. And so I could break this apart into the product of the limits, and I can see that each of these, as n approaches infinity, also approach infinity. So I'm just getting -4 times infinity, or negative infinity. Okay, so that's kind of how you think it through. You only had to deduce that what the limit was. And in this case, it diverges to negative infinity, this sequence. Now I'm going to go to the next board and copy in this problem. This time, we got a slightly different situation as far as the, again, and say the limit as n approaches infinity of 4n factorial divided by n hat n Wolfram alpha seems to suggest that the limit is 0. So the sequence does not diverge. It converges to 0. Let's see if Desmos agrees. Let me hide this one. Whoops, wrong. Okay, and problem number 16. There's 4n factorial over n to the nth. Here's the definition. I'll bring these terms into focus, and we can see that as n is getting bigger and bigger, these dots are getting closer and closer to 0. As a matter of fact, the 10th term of the sequence gives us a value of 0.00145. So it's getting closer and closer to 0 very quickly, as a matter of fact. How could I show that or deduce that without looking at a graph? Well, one thing we could do is the same technique we used on the previous board. Again, let's write out some of the terms of the sequence. So a sub 1 would be 4. A sub 2 would be 4 times 2 factorial over 2 to the second, 2 times 2. So that looks like it's 2's cancel, 2 goes into 4 twice. What about a sub 3? It's 4 times 3 factorial over 3 to the third. 3 times 3 times 3. What about a to the 4? A sub 4. 4 times 4 factorial. 4 times 3 times 2 times 1 over 4 to the fourth. And I'm writing it this way so that you can see that the number of factors in the denominator is equal to the number of factors for the factorial. So a sub n, I could perhaps rewrite this way. Equals still to 4 times n factorial is n times n minus 1 times n minus 2, and I'll keep going till I get to 1. And in the denominator, I'll have n times n times n times n. And if you picture these fractions right here, what happens as n approaches infinity? I could break it apart into the product of the limits of a whole bunch of different fractions, but for example, the limit as n approaches infinity of n over n is 1. And the limit of n minus 1 over n is 1. And the limit of n minus 2 over n is 1. But what about this guy right here? The limit of 1 over n as n approaches infinity is 0. So I've got 4 times 1 times 1 times 1 finally times 0 equals 0. So that's how you could deduce that the limit of this sequence is 0, by sort of rewriting it. So whenever you see a factorial problem like this, start thinking consider rewriting it this way. Starting at n and decreasing n by 1 until we get to that final factor of 1. Okay, hope that helps, and I'll end the video right now.